All right, everybody. I want to work out some practice problems that I have loaded up. There's only on the assignment, there's only 12 practice problems that I've made up, but there are a whole bunch of problems given. So I'm probably on this video, for instance, right here, I'm looking at it. I've got systems of equations. What I'm going to probably do is I'm going to solve the first one on this video in case you need to see it. Okay. In case you would like to see it. I'm going to solve it. I'm going to work through all the steps, but then I'm going to leave this one for you to work on your own. Okay. Same thing here. I'm probably going to solve this one. Leave this one for you to work alone. These are two special cases, so I'll probably do both of those. And then I'll leave you to do that one by yourself and so on. So I'm going to work some of them, and then I will actually work by hand so that I have the hand made notes and you can check your answers against my solution. But I am not going to make the video on the whole entire thing because that would probably be a pretty long video. Okay, so I'll let you know which ones I'm going to do, and then I will just work out by hand the rest of them for you to see later. Okay, so 1A. This one says solve the system by using substitution. Okay, and once again, I'm just going to point out that on this exam, if I tell you a particular method to use, solve by substitution, that's the method I want you to see you do. Okay. If I don't say that, then you're welcome to use any method you want. Okay. But for this purposes or this this problem, I have solved by substitution. So I am going to do what I was told to do. Okay, so this is the problem. X plus y equals 1, 0.3 x plus 0.5 y equals 0.7, and I need to solve by substitution. I'm going to come to this one right here, and I am going to, sure enough, solve for one of those variables. I think I'll solve for y because we're just kind of used to solving for y. So to get y by itself, I'm going to subtract x off, right? Minus x. Y equals negative x plus 1. Okay, so the idea behind substitution is get one of your equations so that one of the variables is by itself. I picked the first equation because both of these have coefficients of 1. That makes it easier for me, okay? If you want to solve by getting this second y equation, this y by itself, you can. It's just more work, so just be aware of that. Okay, then what? Now that I have this, I go to the other equation and I substitute in, right? That's the whole idea. So what do I have? 0.3x plus 0.5 times the y, but instead of the y, I'm going to figure out what I'm going to substitute in. What was it? Instead of y, I'm going to put in negative x plus 1. Don't stop because you're not finished. This was 0.3x, 0.5y equals 0.7. Okay, so you have to finish it out, right? Okay, now, before I go any farther, I see these decimals and I would just like to get rid of all the decimals. I think it'll make my life easier. So I'm going to multiply everything by 10. You can do that as long as you multiply it into every single term. So remember, this is one term here. You could have done it up here too if that made you, if this seems easier to do it right there before you substitute, do it right there. That's fine. I just want to get rid of those decimals. So I'm going to have 3x plus 5 times negative x plus 1 equals a 7. All right. Now what? Now I'm going to distribute that 5 in. 3x plus, or minus actually, plus a negative 5x. Okay, and then plus a 5 equals a 7. And this is the idea behind substitution. Once I plug in, instead of y, I'm sticking this stuff in, the y values or y variables go away, and all I have left is x's. So I can combine these like terms. Minus 2x plus 5 equals 7. I can get rid of that 5 from both sides. Negative 2x equals a positive 2, right? And I can solve by dividing by negative 2. X equals negative 1. Okay. And then, of course, we know we're not done because we only have the x value. We need to take that x values, go back to one of those equations. I'm going to go to the first one because I think it's easier in the first one. Instead of x, I'm going to substitute in negative 1, right? So negative 1 plus y equals a 1. And then, of course, we know to get the y by itself. I'm going to add 1. That's 0. Y equals 2. So the point here is negative 1 comma 2. That's my solution for this system. And that's doing it by substitution. Okay, that's what we're after. All right. So again, I'm not going to work 1B. I'll come back and fill in that with my notes later so that you can have the solution set. But for right now, I'm planning on just working through some problems so that we can see all the different stuff. So 2A says solve by elimination. Remembering that elimination means get rid of one of the variables, right? So A says 6x minus 2y equals 4. 5x plus 3y equals 8. Okay. And again, you can get rid of either one of these variables you want to. For instance, if you want to get rid of the x's, I would need to multiply the top by a 5 and the bottom by a 6. That would get me 30. And then one of them I'd have to multiply by a negative. So, like if I did positive 5 here, I'd have to do negative 6 here. So this would be positive 30 and negative 6. Positive 30 and negative 30. Okay, so remember that you want those to go away. But as I look right here, I think this question is much better laid out for me to get rid of the y values because I've already got a plus and a minus. So when I look and say, what can I multiply to get rid of those y's? I say, well, if I multiply the top equation by a 3 and the bottom equation by a 2, that'll be negative 6y, that'll be positive 6y, and sure enough, that'll work it out. And don't forget to distribute all the way through. Okay, so here we go. Top 1 by 3 is 3 times 6x is 18x. 3 times negative 2y is negative 6y. 3 times 4 equals 12. Okay. The bottom one by 2. 2 times 5x is 10x. 2 times 3y equals 6. Oops, sorry, 6y. 2 times 8 is 16. All right. And now this is elimination. Remember, that's the process of adding these together. When I add those, sure enough, those will zero out. The y values will 28x plus 0y equals, that's going to be 28. 28x equals 28. Divide by 28, x equals 1. Okay, so I've got my x value. Plug that back in. That part is the same. And again, it doesn't matter which equation I go into for that part. I just need to plug it into one of them. So I'm going to go to the top one. 6 times 1 minus 2y equals 4. I do go back to the original equations because just in case I made some weird mistake here, oh, excuse me, it'll help if I go back to the original. Okay, so 6 minus 2y equals 4. Get the 2y by itself. I'm going to subtract 6 on both sides. Those will go away. That's a negative 2. Negative 2y equals negative 2. Hey, look, y equals 1. That's an interesting point. 1, 1 for my solution there. Okay. But that's the way that elimination works. Okay. So you guys do 2b on your own if you want some practice. And then we're going to look at what's special about 2c. It is negative 5x plus 15y equals 10, and positive 5x minus 15y equals also 10. And these are supposed to be elimination. Now, hopefully you automatically are keying in going, oh, something's going to go weird here. Okay, I hope you see it's going to go weird because I've already got a negative and a positive of the same thing here and a positive and a negative of the same thing there. So all I'm going to have to do is add those together, right? And they will automatically eliminate. Now, the problem is this. 5x and negative 5x, that's 0x. 15y and negative 15y, that's 0y. And when I add these together, I get 20. 10 plus 10 is 20. So what we're saying here is 0 equals 20. Okay. Is that true? No. Okay. That's a false statement. Okay. So what happened whenever we got a false statement? We said those were going to be basically those are two parallel lines, right? Is what's going on. They have the same slope, so they're never going to touch. So that means no solution. Okay. And you don't have to necessarily remember the parallel line part. Hopefully that helps you remember stuff. But what you do have to remember is, hey, 0 can never equal 20. That's not going to work. So this is no solution. Absolutely. All right. That's one of our special cases. They're parallel lines, so they never touch. And then sure enough, I give you another special case here, 2D. And again, I hope you can kind of look at them and go, ooh, something weird's happening. Because as I'm looking at these, we even have the same basic numbers. Sometimes the coefficients are the same, so you might not know it from the beginning. But I'm looking at these going, oops, there's going to be a problem because this is supposed to be elimination. Add them together. Again, this will go away. Again, this will go away. All of those are eliminated. I've got the left-hand side as 0, but what happens on the right-hand side this time? It's a 0. That's what I'm hearing. 10 minus 10, that's a 0. Is this a true statement? Yes. That's always true, right? Always true. So that means there's an infinite number of solutions. And what we normally say is just let one of the variables be a number, right? In fact, my math lab says something like probably let y be any real number. Okay. And then it'll solve the other one, the x guy, in terms of the y. So you just got I don't care if you know that for the test. I just care that you know, hey, this is always true. So that's an infinite number of solutions. And remember, that's the case where the line, there's one line, and then here's the other line right on top of it. So they share all points. That's what that is. Okay. This one was a never touches. That's the idea. Because remember, these are all linear equations for us. They don't have to be whenever you're doing a system of equations. You could have quadratics or other stuff. But for us, these are all linear equations. So those are our two special cases. One is no solution. One is an infinite number of solutions because they either don't touch or they share all of their points. Okay. Again, you can do 2E. I'll fill in the blanks on my notes later. Number 3. This one's actually a 3-part problem, so we'll do them all. Part A says, write the system as an augmented matrix. Okay. Remembering that augmented means that we're going to start out with our regular matrix, probably going to be a 2 by 2 or 3 by 3, and we're going to augment onto it by adding the solution, right? A column for solution. X minus 2y equals 1. 2x minus y equals 5. Okay, so part A just says write the system as an augmented matrix. So here we go. I should have a column for x's. I should have a column for y's. And then I'm going to dot, dot, dot. And over here, I'm going to have a column for the constants or the numbers, right? Okay. And remember, when we go into this augmented matrix, we're not going to actually use the variables. We just use the coefficients. So what's the coefficient out in front of this x? It's a 1. What's the coefficient in front of this y? It's a -2. And what's the number of the solution here? It's a 1, right? And this would be what? 2, what goes for here on the y? -1, and what goes here? 5. Okay, so that's an augmented matrix, and what makes it augmented is I've added on the constants back here at the back. If I dumped that, we'd be looking at more of a square matrix here, right? They don't have to be square, it's just that that's usually what we end up with, okay, without the augmented part. Okay, so now show proper row echelon, show proper row operations, proper row operations to get into reduced row echelon form. Okay, so remember what we're saying here is we want to take this guy and we want to make him into 1 0 0 1, and then whatever's on this side over here, that'll be the solution, right? So that's just some numbers. But that is what it looks like. Remember that we talked about is the matrix identity. And this is how we're going to start out looking. We're going to make this look like this. And then we will have the answer. So these will be my answers. Okay. So let's start out with my actual augmented matrix. 1, -2, 1, 2, -1, 5. Okay, I've got that guy, and let's remember our proper row operations. I could switch 2 rows if I wanted to. I don't want to. I can multiply any row. Okay, so here are my abilities. I can switch. I can multiply a row by a non-zero number, or I can multiply a row by a non-zero number and add to another row. Okay, only changing one of the rows with that. Those are my 3 valid row operations that we've been doing. Okay, and remember, I want it in this format. So I want a 1 right here. This is nice because I already have a 1 there, so I'm going to leave it alone. And then, remember, I go counterclockwise. So first, I'm going to get the 1. Second, I'm going to get this 0. Third, I'm going to get this 1. And fourth, I'm going to get this 0. Okay, so I've got the 1, so I'm good. I need a 0 right here. Okay, so what can I multiply? Okay, and remember, whenever we get zeros, whenever we're looking for zeros, we're almost always multiplying the other row by a number and adding it into this row. Okay, so in other words, excuse me, I don't want to change the top row, so I'm going to leave it like it is. 1, -2, and a 1. It's going to be just like that. But if I want to make this guy into a 0, I can say, hey, what if we multiplied this top row by -2? Well, that would be a -2, and if I add it down to there, -2 plus 2 gives me a 0, right? Okay, so that's the idea here. And then, of course, don't forget to multiply this all the way through. -2 times -2 is a +4, plus a -1 is a 3. -2 times a 1 is a -2, plus a 5 is a 3. Okay. So normally, if I need a 0, I'm going to multiply the other row by a number, and I'm going to add it down. Here, the next thing I need, I've got the 1, I've got the 0. I need a 1 right here, right? And normally, whenever I want that 1 there, if I can't like switch a row to make it happen or something like that, it's normally going to be multiply. I'm going to use the second operation. Okay. So in other words, to get zeros, I normally use the third operation. To get ones, I normally use the second operation. So what can I multiply this second row by to get me a 1 right here? I'm thinking if I multiply it by 1/3, 1/3 times 3/1, that'll give me a 1, right? Okay. Am I changing the top row? Not at all. So I'm going to put that in there. 1, -2, and 1, because I am not messing with him. I'm only messing with this bottom row. And because we got this 0 before we're trying to make this into a 1, we can say, hey, when I multiply 1/3 times 0, what happens there? 0, right? It stays, which is what I was after. And then 1/3 times 3, well, that gives me the 1 I'm after. Good, good. And 1/3 times this 3 is still a 1. Okay, so just be aware, if I get this 0 first, that's why I told you to go counterclockwise. 1, 2, 3, 4. If I get that 0 first, when I multiply through by some constant to make this number into a 1, it's not going to mess with my 0. So I'm not undoing any kind of work that I was already happy to have done. Okay. Now, I've got the 1, I've got the 0, I've got the 1. I need this 0 up here. So I need that to be a 0. And am I changing the bottom row? Nope, I'm not going to change it at all. So I'm going to go ahead and rewrite it so I don't mix it up any. Okay. And then I'm going to say, look, I want a 0. So to get the 0, it's normally the multiply and add thing, right? What can I multiply the 1 by and add here to get a 0? I think it's times 2. Okay. And then here's the cool part. 0 times 2 is 0 plus 1, that's 1. Because I've got this already as a 0, when I multiply and then add up, it doesn't change this value. That's what we want to happen. 2 times 1 is 2 plus -2, that's my 0. 2 times 1 is 2 plus 1, that's a 3. Okay. And now I say, hey, I'm done. This is my reduced row echelon form. Okay, that's what I'm after. Okay. Do I have 1, 0, 1, 1, 0, 1, 1, 0, 0, 1? Do I have that? Yes, 1, 0, 0, 1. And then I've got numbers over here, but we really didn't care about that, what those numbers are. We just want to get it into this format right here, 1, 0, 0, 1. All right. And then part C said, okay, what are your answers? Whew, I'm sorry. What are your answers? Solution. X equals what? Y equals what? Okay, well, read it. X, Y, and a number value, right? What's this first row tell me? 1x plus 0y equals 3. So x equals 3. What's this second row tell me? 0x plus 1y equals some 1. Y equals 1. Okay, there's your answer. 3 and 1. Or, of course, we all know we could do that. 3, 1 if we want to. All right, we got our solution. Yay. So number 3 didn't have various examples. It was a 3-parter, so we did it. So that's it for that. Let's take a look at number 4. This one does have 2 parts, so I will do 4A. You can do 4B on your own, and we'll see how that goes. So it says solve using matrices. And it just gives me a system of equations, and it says x plus y equals 1, 3x plus 2y equals 14. Okay, solve using matrices. Well, before I go on, I'm going to have to switch pages here. Let's go ahead and write this as an augmented matrix. What's the coefficient here? 1. What's the coefficient here? 1. Okay, and my number part is a 1, right? What's the coefficient? 3. What's the coefficient? 2. And the constant here is a 14. So remember that changing it into the matrix, we just use the coefficients over here, drop the variables. We're not going to deal with the variables. And then on the right-hand side of that line, those are the constants that we set equal to, right? All right. So I'm going to come back to this. I'm going to come over here and I'm going to come back to this. I will look at it in a little bit. So it says solve using matrices. So solve means get down to like an X value and a Y value, right? The nice part is I've already got my 1. So I'm not going to have to mess with anything. I want the 0 there. So what I'm going to do is I'm going to rewrite row 1. because it's got the 1. I don't need it. But I need a 0 here. What can I multiply here by? I think it's a -3, and I'm going to add it down, right? 1 times -3 is -3 plus 3. That's my 0. That's what I wanted. -3 times 1 is -3 plus 2 is a -1. That's what I wanted. And don't forget to multiply all the way through. -3 times 1 is -3 plus 14 is 11. All right. Hey, this isn't going to be too bad. I think we'll be all right on this one. So let's do the next thing. We're close, right? We've got the 1, the 0, and we want this guy to be a 1. It's a -1 right now. So what can I do? I can just multiply by -1, right? Am I changing the top? Nope. So rewrite that top row. And then here, anything times 0 is 0. -1 times -1 is a +1. And don't forget the 11. That's where I usually make my mistakes if I do. The -1 times the 11 is a -11. Okay. So I've got my 1, I've got my 0, I've got my 1. Last but not least, we need to make this guy a 0. And one more time, that means multiply the bottom row by some number and add it up, right? So, well, these are 1s. So I think I can do -1 and add it up and we'll be okay. I'm not changing the bottom row, so I'm going to rewrite him just the way he is. 0, 1, -11. And let's see. -1 times 0 is 0 plus 1 is 1. Yay. -1 times 1 is -1 plus 1 is 0. Yay. That's what I want it to look like, right? So just keep on going. We're almost there. -1 times -11, that's a +11, plus 1, that's a 12. Okay. So what is my answer? X equals 12. Y equals -11. So I've got a point, 12, -11. There we go. All right. Solve using matrices. All right. So you've got another example of that in number 4. Go through for that. Number 5. Hang on. Sorry. Trying to look at these. I don't really want to do a word problem right now, but I'll do it so we can get through this and be okay. Sorry. I'm writing down the answer I got so that we can see it. All right, cool. So word problem for number 5. It says, and again, there's not multiple word problems, so we'll just work it together. I'll work all the parts. It'll be okay. A company rents small trucks. Here it is. They want to purchase 25 trucks to rent out. 2 kinds of trucks are available: 10 feet with 350 cubic feet or 14 feet with 700 cubic feet. They want a total of 10,500 cubic feet of space. How many of each truck should they buy? Okay. Now this is going to be a system of equations and you can solve it. Oh, excuse me. You can solve it any way you want to. I don't care. But what I think is let's talk about the 2 systems first. Okay. So there's 2 equations that are going on. First is the number of trucks. Okay. What we know is they want 25 total. Okay. But do we know how many we have that are going to be 10 feet long? Nope. So we're going to let X equal the number of 10 foot long. And we don't know how many 14 feet, so I'm going to let that be my other unknown or my other variable, number of 14-foot trucks. Okay. So those are going to be my stuff. So for number of trucks, I have one equation. It's going to be however many 10 footers, so X plus however many 14 footers, X plus Y. And what's that going to total out to? 25. There's one of the equations. Okay. And so you should hopefully be able to set some of that stuff up, right? That's the number of trucks. The other thing that they're asking me about. Uh-oh, hang on. I don't know why that happened. That's weird. Okay. Somehow I clicked the mouse by accident. Sorry. The other thing that they're asking me about is about the square footage, okay, or cubic footage. So let's make that cubic feet. Okay. And of course, they want a total of 10,500. And so they want to figure out, okay, what's going on. So hang on. If I have X 10 footers and the 10-foot ones carry 350 cubic feet, then how many cubic feet do I get from that? It's 350 cubic feet per however many 10 footers we have, right? So that's times X. Okay. For if I had one truck that was 10 foot, I'd have 350. If I had two trucks that was 3 foot, I would have 700. Three trucks, 10,000, or no, sorry, 1,500. Sorry. So 1,000, oh my gosh, I can't do that math in my head. 350, I think it's 1,500. I see real fast, sorry. 350 times 3. Now I just want to know. 1,050. There it is. Couldn't put the 0 in the right place. Okay, so however many I have, we're going to multiply it by 350. Okay. What about the total cubic feet for the 14 footers? Well, those are Y, if there's 5 of them, if there's 10 of them, or whatever, and they each hold 700 cubic feet, right? So this is what we're talking about. Depending on how many of each we have, that's what we got. And together, we want that to add up to be the 10,500 square feet, right? So we ought to be able to write that equation, I hope. Let's see. 350x plus 700y equals the total square cubic footage, 10,500. Okay. So I have two equations and I have two variables. One's an x, one's a y. And sure enough, it says, how many should we buy? Is what it asks. Okay. How many of each truck should they buy? Okay. Well, that means I need to know how many are 10 footers and how many are, what's the Y, or how many 14 footers, right? So let's put these together. Let's make a system of equations. X plus Y equals 25. 350x plus 700y. 10,500. Okay. And honestly, I just don't care what method you use here. I think I'm going to do an elimination method. You can do it however you want to. I'm going to drop out these y values. Okay. Just because I like getting rid of the y's. In order to do that, I've got 700y here. I'm going to have to multiply this entire top equation by negative 700. Okay. If I do that, I'm going to have negative 700x minus 700y equals, got to get my handy dandy calculator out. 25 times 700 is 17,500. Okay. So that's the top equation. I'm not messing with the bottom equation. 350x plus 700y equals 10,500. Okay, that's after I multiplied the top by negative, oh, hang on. It was negative 700 times 25, so this is a negative. Be careful, careful, careful. We all drop negatives sometimes. Be careful. Negative 17,500. Okay. I see that what I wanted to do is happening. The 700 and the negative 700, those are going away. So I can add these together and eliminate them. I think, sorry about that. Dang it. Negative 700 plus 300 is negative 400. X. Okay. Negative 17,500 plus 10,500. It leaves me negative 7,000. Right? Okay. I'm going to divide by negative 400. And a negative is a positive, so I'm just going to divide it out. And it goes 17.5. Hang on a second. Let me play with that. Oh, you know what? It's because Dr. Webster's math is wrong. Negative 700. Let's use the calculator. Sorry about that, guys. Negative 700 plus 350 is not 400. It is negative 350. Some of you were probably screaming that at me, right? Screaming at the thing. Wait, that's not right. Negative 350x equals negative 7,000. I'm sorry, guys. There we go. Okay, try again. Divide by negative 350. You know what gave it away, right? What gave it away? 17 and a half trucks. Can we do that? Nope. So hopefully this comes out better. 7,000 divided by 3,500. Oh, that's 20. Yay, that's much better, right? Negative divided by a negative is a positive, and we get 20 of those 10-foot trailer or trucks, right? Okay. Now, the next one should be pretty easy because I need to substitute in the x to get my y value. Would you rather substitute the x in here or would you rather substitute the x in here? Please say here. 20 plus y equals 25. So we know that y equals what? 5. We needed 25 trucks. 20 of them are here. So 5 of them are here. So it's 20 comma 5. That's my solution. And that means there are 20 10-footers and there are 5 14-footers. Okay. So sorry about that arithmetic mistake. I did get all the negatives in that time. So we're good there. And I think that makes sense for number 5. Okay. So, yes, I will pretty much promise you're going to have a word problem on the test. So, if that doesn't make sense, then go back and make sure you can rework that and everything's good so that you're not going to be like, oh, I don't know what you did there. So, try it and see. All right. So, done with that. Number 5. Next, 6A. 6A says add if possible. Okay, and it's 2 matrices. And I've got 2, -6, and a 1. And the second row is 8, 5, and a -3, plus -3, 4, -1, and 4, -5, and -2. Make sure I got all my negatives in there. Okay, so this is adding. So if you'll remember, how do I add? I have to check first that this is a 2 by 3 and this is a 2 by 3. And remember to add, we need the same dimensions, same size. Same size matrix, okay? This is a 2 by 3, this is a 2 by 3. So I can indeed add. And what do? I do it position by position, right? So coordinating spots. So here I can add the 2 plus the -3. 2 plus -3 is -1, right? And I can add the -6 and the 4. -6 and 4 is -2. Excuse me. And we can add the 1 right here and the -1. And 1 and -1 is a 0. Absolutely. And then what? 8 and 4. That gives you a 12. 5 and -5. That gives me a 0. And last but not least, -3 and -2. That's a -5. Okay. So it said add if possible. I can because they are the same dimensions. That is my answer. What if they weren't the same dimensions? Well, hint, hint, B might be something like that. Can I do that? Probably not. So actually, I'll just go ahead and put 6B right here. Cannot add. Not the same size. Same dimensions. And by dimensions or size, we mean row by column, right? That's how we That's how we've been denoting our sizes on our matrices. All right, good deal. Number 7, subtract if possible. So A says 2, 0, negative 3, 6, minus 0, negative 4, negative 1, 0. And again, same things going on here. If they are the same size, then I can subtract them. This guy's a 2 by 2. This guy's a 2 by 2. What's the answer going to be? Same size, right? 2 by 2. Okay. So sure enough, we can do this. All right, let's see. 2 minus 0 is 2. 0 minus a negative 4, be careful. Minus a negative 4 is a positive. 0 plus 4 is 4. Negative 3 minus a negative 1. Negative 3 plus 1 is negative 2. And 6 minus 0 is 6. Okay. So absolutely, that's what we got. Okay, sure enough, we can do it. They are the same size, so we can subtract, and we do it position by position. Okay, so there's a 7B and a 7C, and I'm going to let you do those. I'll come back with the answer key later. Let's skip on to 8A, and it says multiply if possible. Okay, and we've just been doing a good chunk of those, I think, in the last couple of sections, so hopefully this is the most recent material. Hopefully everybody's okay. So I've got 2, negative 3, 1, 2. Sorry. And I've got 1, negative 1, 0, negative, 0, negative 2. Careful, careful. All right. And to multiply, remember they have to have not necessarily the same dimensions, but they have to have the same inside numbers. So the columns on the first matrix has to match the rows on the second matrix. If we do, we know our answer is going to be whatever's left over. In this case, it is a 2 by 2, but it's not always that, right? Okay. And remember, how do we do this? Row times column, position by position. 2 times 1, that's a 2, plus negative 3 times 0, that's a 0. That goes in the first row, first column's position. Okay. Then we go first row, second column. That's going to go in the first row, second column position. 2 times negative 1, that's a negative 2. And plus negative 3 times negative 2, that's a positive 6. Okay, we'll come back and clean this up in a minute. And then we've got second row, first column. It's going to go in the second row, first column position. 1 times 1 is a 1. Plus 2 times 0 is 0. Absolutely. 1 plus 0. And then last but not least here is second row, second column. So it goes in the second row, second column position. 1 times negative 1 is negative 1. Plus 2 times negative 2 is negative 4. And there we have it. We just need to clean that up a little bit. So what do we got? It's still a 2 by 2 matrix. 2 plus 0 is 2. Negative 2 plus 6 is 4. 1 plus 0 is 1. Negative 1 plus negative 4 is negative 5. All right, there you go. So it is possible to multiply it, and we did do it. Okay. Remember that these inside numbers have to match. If they don't match, you cannot do the multiplication. So that's 8A, and then there's an 8B and an 8C, and I think you can do those. So try them, see what you get. And then what? 9. 9's got a whole bunch of parts, and I'm going to do, I don't know, 2 or 3 of them. Okay, not all of them. We've got 3 matrices that are given to us. A is 2, negative 1, 3, 0, 4, and negative 2. B is negative 3, 1, 2, and 5. And C is -1, 0, 2, 4, -3, 1, -2, 3, and 5. Okay. So we're going to use those three matrices to do a whole bunch of stuff and see what happens. Okay. So for instance, I'm going to skip down. Well, first, let me first say, for instance, A says find A times C. Well, I'm not going to do this one because I just did a multiplication one, but let's talk about it. A is a what? 2 by 3 matrix. And this guy is a 3 by 3 matrix. So can we multiply those? And the answer is yes, because the inside numbers here match. Okay, so if the columns in the first matrix and the rows in the second matrix are the same, then they match. And we know that our solution here, sorry, I can't spell, is going to be a what? Whatever's left over, 2 by 3. Okay, so you can multiply and you will be fine. But on something like B, be careful because it says C times A. Let me switch those. That would be a 3 by 3 for the C guy and a 2 by 3 still for the A guy. Now look on the middle guys, the inside. Number of columns here, number of rows those. Those do not match. So what do we think? Can't multiply. Okay. So be sure you're going back and checking all of these like we told you to check so that you can, make sure you got it all right. Okay. There's a part C. It's an addition. I already did an addition, so I'm letting you do that one. See how you do. D says find B squared. Okay. Well, B squared means take this B guy and multiply by himself, right? That's what squaring something means. Take that guy and multiply him by himself. Before I do that, I need to check. Can I do it? The answer is yes here because it's a nice, pretty square matrix. So it doesn't matter which order, so to speak, I put those two matrices. So sure enough, I can do this. And when I get finished, I'm going to have a 2 by 2 matrix, right? So let's see what we get. Okay. -3 times -3 is a +9, plus 1 times 2 is a 2. It's the first row, first column. First row, second column will be right here. Gonna have to do some work here. -3 times 1 is -3, plus 1 times 5 is a 5. Okay. Second row, first column. And again, it might help you to cover up the stuff you don't need. 2 times -3 is -6. -6. 5 times 2 is a 10, so -6 plus 10. And second row, second column is 2 times 1 is a 2, plus 5 times 5 is a 25. Check my arithmetic always. 2 plus 25. So I think we've got 9 plus 2 is 11. -3 plus 5 is 2. -6 plus 10 is 4. And 2 plus 25 is 27. Absolutely, I think that's all right. Okay. So we can do that one. I'm also going to go ahead and do E just because in this video we haven't done one where we did a scalar multiplication or multiplied one of these by a constant. So it says find 3C. Okay. So if you remember, okay, I'm going to multiply 3 on the outside of -1, 0, 2, 4, -3, 1, -2, 3, and 5. If you'll remember, I can do this with any number on the outside. I can multiply a constant through, and it will get multiplied by every, excuse me, every single term inside of the matrix as long as this number that I'm multiplying by is not a 0. right? If I multiply a 0, it wipes out that whole thing. So that doesn't make sense. Don't do that. Okay. But we could do fractions, we could do decimals. You can do whatever you want here. Okay. So I can multiply this 3. So I'm going to. The nice thing is it's just a constant. So we can do this. 3 times -1 is -3. 3 times 0 is still 0. 3 times 2 is 6. Then I keep going, right? Because it's times the entire matrix. So it's multiplying a constant number by the entire matrix. That's what this says. Take the 3, multiply it by the entire matrix C. Okay. So here we go. 3 times 4 is 12. 3 times -3 is -9. 3 times 1 is 3. And then we got 3 times -2 is -6. 3 times 3 is 9. 3 times 5 is 15. Okay. So it's not that one's not a tough process. It's just a matter of remembering, oh yeah, that's what they're asking me to do and multiplying it out. Okay. So with that in mind, I think I will say um, you can do the rest of those. There is one that says it's part H. I'm not going to do it for you, but you can look at it. Part H says 2 times A times C. Okay. So what I would do is I would multiply the A by the C first. Do this in order, people. Okay. So get your matrix first. So now I would do 2 times AC. Okay. And before I can do that, I got to figure out the dimensions here. So let's go back up here. A is a 2 by 3 and C is a 3 by 3. So can I do AC? The answer is yes. In fact, we already talked about that. Oh, look, you already did AC here. So you ought to be able to get the solution from A and multiply all of those by a 2, and you should get there. Okay. But the answer is yes, you can do this. So figure it out. Do the math. You can do it. All right. That is number 9. Number 10. More recent material. A says, are these inverses? Okay. So A is 3, -4, -2, 3, and 3, 4, 2, 3. Are these inverses? And remind me how you know. These are inverses. 2 matrices are inverses if m times its inverse, m to the -1, gives me back the identity matrix, right? And in this case, the identity matrix here is a 2 by 2. Oh, sorry, 1, 0, 0, 1, right? Okay. So if I multiply these 2 matrices together and I get the identity matrix, then the answer is yes. If I multiply them together and I get anything else, the answer is no. Okay. That's the process you're going to follow here. So there's 2 parts here. I'm going to do A. I'll let you do B. Okay. So let's try it and see. 3, -4, -2, and 3. And we're going to multiply it by times 3, 4, 2, 3. Position by position. First row, first column. 3 times 3 is 9 plus -4 times 2 is a -8. Okay. First row, second column. 3 times 4 is 12 plus -4. Sorry. -4 times +3 is -12. Okay. Good deal. Second row, first column. -2 times 3 is -6 plus a +6, 3 times 2. And second row, second column. -2 times 4 is -8. 3 times 3 is a +9. And sure enough, I feel like these are going to be inverses because 9 plus -8 is 1. 12 plus -12 is 0. -6 plus 6 is 0. And sure enough, -8 plus 9 is a 1. So these are inverses. Absolutely. Okay, and if you do part 10b and you don't get that as your answer, then I don't know what to tell you because it's not an inverse. There you go. That's how you know. If you don't get 1001, your identity matrix, then it's not an inverse. Oh, I don't have to skip pages. All right, so you guys, actually, I'm going to skip pages because I'm going to do 10b. When I load this up, I'll have it in there. All right, number 11. Again, there are two parts. Find the inverse. Okay, part A says 2, 6, 3, 9. And I'm going to not close that out because I don't want to have to write it again. Remember, to find the inverse, what you do is you take your matrix and you augment it with the identity matrix, right? Okay, which means I'm going to add on here 1, 0, 0, 1. Okay, and I want to transform this to the identity matrix augmented with some new guy, B. And if I can find that matrix, then that matrix will be my inverse, right? Y'all remember that? Okay. So that is indeed our process here. So I need to take this guy and I want to turn it into the 1001. And I don't care what's going on over on the right-hand side because that'll just be like my inverse. It'll be fine. So first I want a 1 here. I don't have a 1 there. I'm going to multiply everything on the top row by 1/2. 2 times 1/2 will give me a 1, right? I'm not changing the bottom. 3, 9, 0, 1. I am changing the top. 2 times 1/2 is 1. 6 times 1/2 is 3. 1 times 1/2 is 1/2. And 0 times 1/2 is 0. Okay. So I've got my 1. We've done this several times now, so I want this to be a 0. What can I do? I think I can multiply by a -3 on top and add it down. Okay. I know I'm working through these practice problems really fast, but hopefully by this time you've done all your homework, you've taken the quizzes, you've done all that, and you can move pretty quickly through these by now because these are just practice problems. Hopefully you know what you're doing, right? I'm not changing the top row, so I'm going to rewrite it. 1, 3, 1/2, 0. And now -3 times 1 is -3 plus a 3. That's my 0. That's what I wanted there. -3 times 3 is a -9. -9 plus 9 is a 0. Uh-oh, now we're going to be in trouble, right? Keep going. We're not done yet. -3 times 1/2 is -3 halves plus a 0 is -3 halves. -3 times 0 is 0 plus 1 is 1. Oh, we are in trouble. Dang it. Okay. What is this telling me? 0 equals some number, right? Okay. Anything other than 0 is a lie, right? And these are not 0. So this says 0 equals some number. And we know that that is not true. That's a false statement. And so that is no solution, right? Okay. What does that mean for us in terms of the inverse? If there's no solution, then that means we don't have an inverse, right? Okay, so no inverse. Dang it. Okay. Not working for us. That's what that means. Okay. So just be aware that occasionally that happens and you're going to have to work it out. There is an 11b, so I'm going to let you work on that. And then last but not least is problem 12 with multiple parts. Okay. And problem 12 with multiple parts, I'm going to do, and they all say find x and y. I'm going to do A. And then I'll let you work out B and C. Okay. It's 1, -1, 1, -2. And then my variable matrix is XY. And then my solution over here is 5, 7. And hopefully you've watched that last video on this so that you know. Oops, let me scoot. I'm sorry. You know what this means. I'm going to multiply first because I got to simplify the left-hand side before I can do anything else. So can I do that? This is a 2 by 2. This is a 2 by 1. Yes, my answer is going to end up looking like this. It's a 2 by 1. So let's see what we got. 2 rows, 1 column. 1 times x is x. Negative 1 times y is negative y. Okay. Second row, first column still, so it's still right here. This guy. 1 times x is x. Negative 2 times y is negative 2y. Okay. Now I have the same size matrices, right? This is a 2 by 1. This is a 2 by 1. They are the same size. So now I can just kind of read them off row by row. X minus y equals 5. And this row says x minus 2y equals 7. Sure enough, now I've got a system of equations. I think that I can just multiply and get this okay. So how about if I multiply, let's get rid of the x's. I think if I just multiply this top row by negative 1, I'll be okay. All right, so how about negative x plus y equals negative 5. Be careful because I need to distribute all the way through. And then I've got x minus 2y equals 7. I didn't change those. On the bottom, it looks just the same. Top, I just changed the signs. Okay, add them together. The x's will eliminate. And now I've got negative 2y plus y is negative y equals negative 5 plus 7 is a 2. Y equals negative 2. That's not bad. Okay. To get your x value, I'm going to plug it in right here in that top equation. X minus, I've got a negative 2 equals 5. X plus 2 equals 5. X equals, subtract the 2 off both sides, 3. So I've got the point 3 and negative 2. And there we go. So there's 2 more of those. See if you can do them. And I will post this video so you can take a look at it. And then whenever I get a chance to finish wrapping up the solution set, I will do that and let you know that as well. All right. That's it. Good luck studying for your test. See you soon.